Hi, I'm Elaine and I'm Head of Quality Control here at E3D. It's my job to ensure all products leaving our doors are of the E3D standard. Let me take you through a typical day in E3D Quality Control Department. First thing to note is that all our QC data is logged. In some cases, like when working with the Keynes, this information is automatically logged and databased. In others, I have to type it in manually. In today's world of QC, data is king. And being able to look at our past data is really useful because it allows us to see errors in parts which keep occurring or look for trends in data which may indicate a wider issue. We measure a percentage of parts depending on the nature of the part in question and its complexity. Now, let me introduce you to the Keynes. The Keynes is our workhorse here at the QC department and can perform a wide array of checks depending on the part at hand. Most QC parts will be inspected on this machine. The Keynes combines a high-resolution optical microscope with computer vision, allowing detection of features such as lines and circles, which we can then measure, for example, the diameter of the nozzle orifice. The Keynes is easy to set up, quick to run, and can even auto-detect parts. If I put down, for instance, a nozzle, the Keynes will recognise that this is a nozzle and then start measuring automatically against information that's provided from the engineering drawings. And there you go, it's as simple as that. When necessary, the Keynes uses a probe. This allows me to measure the distances between features which are hard to detect visually, such as blind holes or matte black parts, such as the Humira sink. For example, here we see the Keynes probing a bearing pocket of a Humira sink, picking up the feature consistently every time. I love the Keynes, otherwise I'd be sat here with calipers desperately trying to measure parts and keep my hand steady, and that would be a bit of a bollock. Earlier this year, we had some tool changer bed plates failed in QC. They had no technical faults, but just like a few scuffs and scratches on them that made them really visually unappealing. Many people have been waiting for over a year for their tool changers, and it's really not fair to send out parts in that condition to customers. After inspecting each of these parts by hand, I then created a visual reference standard to ensure this wouldn't happen again. This rich guide consisted of images showing what constitutes a pass, what constitutes a fail, and what other defects production should keep an eye for when handling these parts. We're working on similar guides for our other parts, and our assembly team are really good at spotting visual defects too. Humans aren't perfect, and when involved in production, mistakes can and will occur. We can counteract this through quality control to catch these mistakes before they leave our doors.